Hi guys, right, I'm back again. Going to take another look at this little charge controller that John Norton, aka Nodge, supplied. And he supplied the kit, and I managed to solder it all together. And what you're looking at the moment is I have the charge controller is connected to a battery. The battery is now fully charged. It's sitting at float voltage around about 13.4 volts, close to it. And the LED on the controller is flashing continuously. It's still giving about 150, 160 milliamps, there's 170 milliamps to the battery, but that's all. What I've actually done is, I don't have a solar panel at the moment, so what I've done is I've plugged in this thing here. I'll just turn it off, let you see it. This is just a bog standard 12 volt power supply. I think it came with a Netgear switch or router or hub or something like that. 12 volts, 1 amp maximum. But this is an unregulated power supply, so if it's not plugged into any devices, you put a meter on it, it actually gives you about 16 or 17 volts. So basically it's behaving a bit like a solar panel. A solar panel would want to give you 20 volts, and this wants to give you 16 volts until you plug it into something which pulls the voltage down. So that's what I've done. I have this connected to the input of the solar charge controller, and it has just brought this battery, it was pretty close to being fully charged anyway, but it's just brought this battery up to full float voltage of 13.4 volts. So what I'm going to do now is, this cruddy old battery was in my shed. It's just been used to power lights, so it hasn't been charged for quite a while, so it's probably done about 12 volts or so. So what I'll do is I'll get it plugged in, get it all connected up, and we'll see what happens with this one. So I'll just pause this, I'm back in a second. Okay, we're back. And what I got now is this battery. It was close when I said 12 volts, it's actually 12.3 volts. I haven't got the charge controller turned on yet. So let me count the pulses. 1, 2. 1, 2, 3. Yep. That's 12.3 volts. So I think I need to reset that. It's showing a current when it's not actually, there isn't any current running. So let me just reset and zero this. And we'll connect it on. And there we go, sure, it's almost 0 milliamps. 12.3 volts. Alright, at the moment all this is drawing power. So now I'm going to flick a switch, and hopefully it won't let the blue smoke out. Key contact. Ooh. What happened? Well, we're now getting 1 amp going through the charge controller into the battery. The battery's gone up to 12.4 volts. And so far, nothing bad has happened. It's cold. I don't actually recall what the power rating of this controller is, but I'm pleasantly surprised that it's handling 1 amp okay. It's dropping down a little. Voltage is climbing. So what I'll do now is I'll leave this connected and come back in half an hour or so and just see what's happened. And hopefully we won't have burnt the garage down. See you in a bit. Okay, well it's now approximately 30 or 40 minutes later. This battery is now at 13 volts, very close to it. The current going into it is now down to 400 milliamps, close to it. The little charge controller is flashing away. 1, 2, 3, 13 volts. 1, 2, 3, and nothing, so that's 13 volts. 1, 2, 3. Oh, 13.1. It's a little bit out. It seems to be out by close to 1/10 of a volt or so. But it's only an indicator. It's not really that important, so I'm not too concerned about that. The important thing is, let's just check on the temperature situation. Stone cold. Absolutely not a problem. Now, I just reread the instructions that came with this little controller, and it does say that it can handle a 100 watt solar panel going into a 12 volt battery. So 100 watts, 12 volts, what's that? About 78 amps, something like that. So it can handle my 1 amp power supply without any difficulty whatsoever. So anyway, what I'm going to do now is I'm going to leave this overnight. It should charge up to 13.4 volts. I'll come back in the morning and hopefully the battery will be in one piece. It'll be sitting at 13.4 volts. The solar controller won't have gone on fire and burnt the garage down. And everything will be good. So yeah, I am very impressed with this little controller. It's absolutely great. Designed to bring a battery up to float voltage and then just keep it there. Because as you know, or maybe you don't know, but if you don't use some kind of a controller when charging batteries, they will basically destroy the battery. The solar panel will try to bring the battery up to 20 volts, and the battery will just continue going up in voltage until basically the battery is destroyed. So that's why you need the controller. And this particular controller is designed such a way so that it takes a minuscule current, a minuscule amount of power to keep it running, which means that at night, when there is no sun, your battery isn't going to be drained by the controller, which is pretty important. It also means that you're not losing half the power coming out of the solar panel, because in this country especially, we don't get a lot of sun, so we need every ounce of power from our solar panels that we can get. Anyway, that's our little solar Pico PWM5 solar controller, made by John Norton, designed initially by Jullian Ilett and redesigned by John and put onto a smaller form factor circuit board, and it's all built using surface mount components. Mostly I think there's just one 3-hole component on it, but everything else is surface mount. Comes as a kit. It's brilliant fun to build. not easy, but I managed it, and I'm completely hopeless with a soldering iron. So yeah, thoroughly recommended. Thanks for watching. Bye. Okay, well, today is now tomorrow. It's now about 7:30 in the morning. So the charger has been working all night, from around about 10 o'clock last night, or 10:30 last night. It's now, we'll just check. I've just come into the garage, and we'll just turn on the meter. It's flashing 13.4, so I'm assuming it's 13.3 rather. So yeah, well, 13.2 actually showing in the multimeter. And we'll just reset this. and make sure it's properly zeroed. Put it on a DC, zero it, and hook it on. Okay, so we're still putting half an amp into the battery. It's been doing that overnight, like I said. Charge controller is still cool. So, seems to be quite happily trying to bring this old half-done battery that's been hasn't been charged in, I'm sure, 6 months, and was being used to power LED lights in the shed. So it's trying to bring it up to float voltage, but it's no surprise that it's going to take it a while to do that. But like I say, still putting in half an amp, still very happily charging away. So that's great. We'll leave this to work and do its magic and come back again later. Maybe by the end of the day it'll have finished charging. But the nice thing about this is you're not straining the battery by putting too much charge into it too quickly. My other battery charger, which is this one, tends to, well, I think it tends to overcharge batteries. I must admit I haven't actually double checked, but I know if I put it on high, it will definitely overcharge the battery, and on low for overnight, not sure. Sometimes I think it doesn't do anything very much. Anyway, we'll leave this charging for the rest of the day. Come back to it later this afternoon and see what's happened.